Welcome everybody to today's AP Calculus AB section. We're looking at section 6.3, volumes of revolution using disk methods. Now, what you see here in the background is an example of some woodworking skills. This person is working on a lathe, and what a lathe does is it takes a block of material and it rotates it really fast so that when you apply a chisel or some other sharp device, it starts removing excess layers of wood. And you can see that we're coming up with this three-dimensional image. Now, the past few sessions, we've talked about areas between curves. We've talked about the volumes of solids when we have known cross-sectional slices. And we're going to apply that today by finding the volumes of revolution. In this example of woodworking, we have this item that's spinning really, really fast around some axis, and we can create these three-dimensional images. We're going to be doing the same thing when we're talking about curves. We're going to be taking some curve and rotating it around the x-axis, the y-axis, or some other axis. What shape does a volume take on? Now, if you think about like y equals x squared as it's rotating around the y-axis, what kind of shape does that have? Here we've got an image, and we can see that we're going to be rotating our figure about some fixed axis. How can we figure out the volume there? Now, when we're rotating, it's going to be creating this three-dimensional image, and we're going to have this symmetry all the way around. So wherever we're looking, we've got all of these cross-sectional slices that are disks. They're flat circles. We know how to find the area of a circle, and using our calculus techniques, we can give a circle some kind of depth there, some kind of thickness that will then allow us to find the volume. So here we've got all of those cross-sectional areas. We've got these disks, flat circles, small little cylinders, and when we stack them, we approximate the volume. Now we know that with calculus, we can take the integral, that gives us an infinite number of disks, and therefore we can find the volume. So the whole idea here is we're going to be taking the curve, we're going to be rotating it about some axis. Think the area of a circle, pi r squared. What's going to give us our area? How are we going to use that to find our volume? Good luck. Check out the instructional videos. We'll see you soon.